Well, now that you know the basic technique of how to stack angle cut rings, we'll move on to lesson 2. I've made a little hike this morning to show off a little more Tahoe scenery. I'm about 10 miles from the shop. But in this lesson, we're going to go through the process of creating thin laminated material and the process of converting this material to what I call a checkered hollow form. It's quick and easy, no math, no miters. You'll amaze your friends. Let's get back to the shop and we'll make one of these checkered hollow forms.
Like almost all woodworking projects, one of your biggest challenges is controlling the effects of cumulative error. What do I mean? Little mistakes, little inaccuracies at the beginning of the project, they accumulate, and by the time you get to the end of the project, you're scratching your head wondering where you went wrong. This particular project requires the utmost inaccuracy in dimensioning material. Otherwise, things don't come together at the end as was your goal. I'll show you one technique for ripping thin pieces of wood on the table saw. These particular pieces are not super thin. They're about 5/16 of an inch wide. If they were much thinner, say 1/8 of an inch, I would use a different technique, and I'll show that technique in one of the later lessons. So follow along as I rip these boards into quite a series of thin strips of wood. The wood is Liptus and bird's eye maple, two woods that have a good color contrast, and they turn with similar characteristics. They're both dense woods, hardwoods. They make a nice combination when paired together.
It's a good idea to check that blade occasionally to make sure it's at a perfect 90 degrees. Here I'm just taking a parallel piece of MDF. I've marked it, I've cross-cut it, and now I'm flipping it over to see if it's still the same. If it is, I know I've got a perfect 90 degree setting on that blade angle. Making nice smooth rip cuts on a table saw requires practice, and it requires a well-tuned saw and a sharp rip blade. Because these cuts are fairly thin, I've removed the blade guard, but keep your guard in place whenever it's practical. I'm using a large, heavy push block. It's not only comfortable, but its mass adds to the smoothness of the cut. It just reduces vibration. To get the best cut, steady pressure against the fence and steady, smooth speed, no pauses. The goal is one even, smooth motion through the blade. To create the very best surfaces, I need to put these through either a planer or a drum sander. This is one way with a planer. Using a sled, I can pretty much eliminate snipe. It's a very light pass, followed by just a couple of swipes with some 80 grit. A drum sander, however, is a lot faster and perhaps more accurate. I've now milled these strips to a perfectly consistent thickness. It doesn't matter what the thickness is, as long as they're all exactly the same. The next challenge is to glue them together into what I call a linear lamination. In this case, it would be like a long, skinny cutting board. If I just apply clamps here, the wood will spread all over the place. It'll be difficult to keep things aligned. So I'm going to use a gluing tray, a jig if you will, and I'm going to build that next. I've ripped a piece of 3/4 inch MDF, about 6.5 inches wide and just a little longer than my strips. And I've milled a piece of hardwood, very straight. A bead of glue and a few clamps joins the two. I'll rip the width of my tray just a little narrower than my material so my clamps don't bottom out. To protect the tray from glue squeeze out, I'm covering it with duct tape. I just happen to have that on hand. You could use any type of tape. Clear tape would work just as well. Notice that the back of my tray is taller than my lamination is thick. That's intentional. I need to put some spacers under the lamination so there's room for glue to squeeze out. Here I'm doing a dry fit. Notice I've got a caul to the outside, long edge, and I've got 3 cauls vertically holding the lamination to the spacers. It just can't slip out of position. And I'm pre-positioning my clamps, just getting ready for the glue job. Our dog Bubby just loves to bark at that air compressor. As for the glue job, there are many goals. Clean surfaces, 100% coverage on both sides of all the strips, and then plenty of clamping pressure to drive all the excess glue from the seams. You have to work fast. You're limited in time, about 5 minutes, and you want that last joint to still be slippery when you put that last clamp on. You want to be able to drive all the excess from the joints. For jobs like this, I like these quick clamps. They're fast, but most any style clamp will work just fine. Regardless of the style of clamp, don't make the mistake of only tightening your clamps once. It takes a while for glue to migrate from the joints, and the clamps will quickly loosen. So make sure you apply added pressure after the initial tightening. Obviously, this jig can be used over and over. Before going to my joiner and planer, I need to scrape off the glue squeeze out. Try to create a relatively smooth surface. Of course, if you have one of these magic scrapers, it's pretty easy work. From my magic scraper, it's over to the joiner and planer to make a few passes. These surfaces have to be perfect. Now, if you got a drum sander, that's even better, but not necessary. In order to split the lamination into 2 equal pieces, I've set my fence so the blade is right in the middle of the lamination. A feather board helps. After one pass, a second pass keeping the same side to the fence, and the blade is adjusted so it doesn't cut all the way through. Now, if you're real good at resawing with a bandsaw, you could skip the table saw step and go directly to the saw. But I like to do it this way. It's more foolproof for me. That center ridge, which is left behind, is easily removed with a pass, maybe 2 passes through the planer. At the beginning of this project, I did a simple calculation so I wouldn't waste too much wood. I've ended up with a lamination 4 1/4 inches wide, a little over 22 inches long. Those dimensions will work out. I'll be able to get 5 different discs out of each one of these boards. If I'd made it wider, then I'd be able to get larger diameter discs, but I wouldn't be able to get 5 because of the limited length of the lamination. Keep that in mind when you lay out your own project. The next step, take a compass, draw this diameters, go to the bandsaw, cut those out. I'll try to get 10 discs from these 2 boards. As you cut these circles out, try not to go inside that line. Outside the line or way outside the line is okay, but inside the line you're going to lose valuable diameter that you can never get back. Okay, now that I have my 10 disc, it's time to design something using this material. I could make a little bowl out of each one of these using the same technique as lesson 1, but we're to the next step. So I'm going to take the measurements from this, the 4 1/4 inch diameter, and they do measure about 0.3 inches in thickness. I'll take that information to a piece of paper and try to come up with a design that I like. I'm not limited, like in the bandsaw ring bowl, I'm not limited to just 1 ring in each diameter. If I need 10 rings of the maximum diameter here, I've got 10 discs to harvest them from. So there's a lot more freedom when you've got this material to work with as opposed to just 1 piece. So let's do some work with a piece of paper and come up with a design that we like. First, I'm folding my paper. The crease will be my center line. I've decided to make my vessel 16 layers tall, my decision. That equals 4.8 inches, or 16 times 0.3, the thickness of my material. So I'm marking the height. I already know my material measures 4 1/4 inches, so that'll be my biggest potential diameter. After I get a shape that I like, I'll take a magic marker, make a nice bold black line, which I can see through the paper in order to duplicate the profile on the other side. The thick black line that I'm creating will represent the wall thickness. It's a heavy wall. I'll probably turn thinner than that. But once that's established, I'll take a ruler, and I'm dividing the height into 16 layers. Those will be the 16 rings that I need. So I'm laying on lines representing each layer, each disc, and I'm numbering the disc. This will be important as I harvest the rings from the different discs. It'll get real confusing if I don't have labels on the different components. I'm laying in a few outside lines just to give me a little more material to work with. Okay, now that I have a blueprint, it's a simple matter of taking a compass, using the point on the center line, and transferring the radiuses or the diameters directly onto the disc so that I can cut those rings and build this vessel. I'll focus first on the largest rings. The outside diameters are approximately the same, so I'm only really concerned with the inside diameters. It's a simple matter of just transferring the diameters. Check them off as you go, and don't forget to label. After laying out the large rings, eventually small rings will fit inside. Here's a disc with 3 rings. Here's number 1, 4, and 10. Notice I've also left room for the kerf. So I've laid out all my rings. I actually had a couple of discs left over, which might come in handy if I have a little problem. Next, over to the lathe with a parting tool to cut them out. MDF makes a nice smooth surface to mount the disc. I'm using just small pieces of double-sided tape. Don't use too much, you'll break your rings getting them off. The tailstock can center it. A little pressure, I'm ready to cut them. Before I cut any rings, I might as well true up the outside just a little bit. It'll make it easier to center things when I glue them together. Before making each parting cut, it's a good practice to look at your plan so you have a picture of the shape of the ring. Some cuts will be perpendicular, others you'll harvest more wood, save more wood if you cut at an angle. Notice my parting tool is always wiggling. That's to keep the kerf large enough for that straight blade to go into that curved cut. Keep your backing plate clean as you go from disc to disc. Go kind of gently on this stuff. These rings are fairly fragile. They will break. If you break one, you probably got extra material. Just take your time at this. Right about now, you might be thinking, why not build this vessel with the half ring technique, using the bandsaw to cut the rings, the half rings, as shown in lesson 1. It could be done that way. However, you'd run a big risk of losing some accuracy. If you had to true up the half rings just a little teeny bit in order to put them together, that tiny loss of wood would lead to an inability to stack all the intersections to create the perfect checkered pattern. So keeping them as full rings from start to finish eliminates that opportunity for cumulative error to slip into the project. In order to center the first ring, that center point has to be perfectly centered. Put it on dry, just touch it with a scraper tool. Check these edges, they've got to be perfect before you glue this on. Check it one more time after you've glued it on. Turn the lathe on slow. Just make sure it's turning the same way it was when you checked it dry. The procedure for preparing the rings for stacking is exactly the same as I showed in lesson 1, so there's no need to repeat that here. To speed up the assembly process, I'm pairing all my rings together. I'm going to build this vessel in 2 pieces. The last seam will be right here where this line has been drawn. I want to get rid of any double-sided tape residue, get them nice and clean with some compressed air. I want everything clean, including my clamps. Perhaps the most difficult part of this project is getting all the seams to line up in their proper place, very, very accurately. Do it dry. Put some reference marks so you don't get confused during the actual clamping. 4-power magnification is a huge help. I can't do it with just my eyeglasses. Work quickly, keep checking the 2 ends. Don't worry about the sides, just focus on the 2 end center seams. If those are dead on, the rest of them have to line up. Before joining the pairs to anything, of course, those surfaces need to be clean. You may have got a little glue on there during the glue job. Here I'm adding a pair to one end of my vessel. You got to get right in there as close as possible with magnification. You only have a few seconds to get it right. If you make a mistake, well, that's what that extra disc was for. Just as with any segmented project, you have to true things up as you go. Flatten the surfaces for the next ring and so forth. There's no reason that pairs can't be formed into groups of 4. What I'm going to show you next is my procedure for the final assembly of a segmented closed hollow form. I usually build these from both the top and bottom ends, thus creating 2 separate open forms. It's my habit to keep the base and top diameters oversized until the end. This provides a little extra stability during the shaping of the main body. Towards the end of the outside shaping, I'll look at the overall profile several times just to improve this shape. A plain background helps to really study the form. Once I'm satisfied with the outside profile, then it's a simple matter of turning the inside to a consistent wall thickness and matching the inside diameters at the last glue joint. With such a small top opening on this vessel, there's no need to sand the inside, but I will leave it with a very smooth, shear-scraped surface. Before removing the top half from its waste block, I can do a little more wood removal, getting that top diameter closer to the final shape, and then part it off so it can be glued to the base. The last glue job, I'm using minimum glue. I don't want glue squeeze out to run down the inside of my vessel. I've got 2 things to focus on. Those center seams have to be dead on, and I want to center the 2 diameters as perfectly as possible. The final clamping pressure can be provided by stacking some weight, or in this case, a bar clamp works very well. Just gentle pressure is all it takes. The final shaping is pretty routine. For myself, I use my trusty 1/2-inch bowl gouge, followed by some shear scraping to get that surface as perfect as I can with my tools. Nobody likes to sand. Just as I finished the bird's eye maple bowl in lesson 1, I applied about 3 coats of sanding sealer, scraping it off in between coats. This filled most of the wood pores and further improved the quality of the surface. Don't forget the inside. It also needs to be thoroughly sealed. And a few seconds of high-speed spinning on the lathe helps drive that sealer into the interior pores. Before applying finish, I power sanded from 220 through to 600 grit, inspected the surface, and then applied the first of what will be 3 to 4 coats of finish. In between coats, I buffed with 4/0 steel wool, and then for the final finish, buffed with a buffing wheel loaded with white diamond compound. Then I parted off the vessel, did a little power sanding on the base before burning in my name and applying finish to the base. As segmented projects go, this one's pretty simple, but let's do a quick review. Select 2 different contrasting colors, prepare the strips, build a gluing tray, laminate the strips together, split the lamination, harvest your disc, design from the disc dimensions, transfer the diameters to the disc, cut out the rings on the lathe, make sure that base is centered, pair the halves together, and build from both ends, true up as you go, focus on that shape, make sure your insides match, join the 2 halves, turn the final shape, sand it, put some finish on it, and don't forget to sign it. This technique of stacking rings from laminated material has probably one of the highest ratios of work to reward in the whole world of segmented turning. A lot of bang for your buck as you look at these other examples. There's no limitation. You can come up with different patterns, different woods, colors, and so forth. Size, you can do the same technique with 2x4s or with little teeny pieces. This group here is different. Instead of all the laminated material being the same, there's two narrow strips matching one wide strip width to get a different pattern. With the leftovers, you can make other vessels. These two bowls came from leftovers from hollow forms. This is a very large piece here, about 13 inches tall, and this little guy next to it, that's less than 1.5 inches tall. Use your imagination and have fun.